through a few questions from a booklet that I've attached. Okay, we'll do these together, and then there's another booklet which you can have a go on your own. So all of these questions have come from actual exams. Okay, most of the time you've only got to do one thing to one graph. Okay, occasionally you might get a question where you have to do two things at the same time. Okay, but make sure now in these questions you're labelling axes and labelling coordinates. So if we look at the first one then, the graph shows the curve of the equation y equals f of x, and they've given us a coordinate of minus 3, 1. We've got to draw the curve of y equals minus f of x. And if you go to your notes, we know that minus means to reflect it. The minus is outside of the bracket, so it means to reflect it in the up and down direction with the x-axis as our mirror. Okay, so this is our mirror across here. So it's exactly the same graph, just flipped underneath. Now make sure you leave a gap, because there's a gap between coordinate A and the axis, and so there will need to be a gap on our one as well. So that would be like our new coordinate A, and our graph will look something like that. Okay. It also says indicate clearly the coordinates of one point on this curve. Well, we only know one point, and that's the one that used to be A. So it used to be minus 3, 1. We've reflected underneath. Now it's minus 3, minus 1. And that's how you get both of the marks for that first question. Now, if you only draw the shape without the coordinate, you won't get both of the marks. You'll just get 1 out of 2. Okay, the next one underneath then. If it'll let me actually scroll the board, there we go. Okay, we've got the same graph again, y equals f of x. It's in exactly the same place. This time the question is asking us to do f of x minus 5. And the minus 5 is inside a bracket, which tells me two things. We're going to be translating it, because it's adding and taking away is translation. It's inside the bracket, so it's left and right, not up and down. And because it's inside a bracket and things go the opposite to what you might think, this graph is actually going to go to the right by 5. Now, if you look at our original coordinate A, which is on minus 3, if I move it 5 to the right, it's now going to be on 2. Okay? The height of the graph doesn't change. The shape of the graph doesn't change. And so what I'll do is I'll draw it in there, look. Okay. Now I've marked the axis, but it says to give a coordinate, so now my coordinate is going to be 2, 1, because all I did was move it 5 to the right. Okay, next question. Another graph, again, y equals f of x. On the same diagram, sketch the curve of y equals minus f of x. The minus, again, like a minute ago, is outside of the bracket, so this is going to reflect up and down, okay, using the x-axis as our mirror. Okay, now we've got 2 points of interest. We've got a cross in there, and we've got a cross in there. Now the x-axis is our mirror, so this sort of point here where x equals 3, that's not going to move because that's on the mirror. But this coordinate up here, which is labelled as 2, well, that's going to have to reflect underneath. Remember, we're doing this. Okay, so 2 is actually going to become minus 2. And the graph, instead of coming down and going through 2, is going to come up and go through minus 2. And then it's going to do that. Okay, so where the original graph went a little bit negative at the end, our new graph has gone a little bit positive, and we've shown where it crosses the axes, minus 2 on the y-axis and 3 on the x-axis. So that's all the marks for that question. Okay, and that's the only one on that page where it looks things. Okay, next one. We've got f of x, and it goes through 1 on the y-axis, and we've got to do a minus 5. Now the minus 5 is stuck on the end. It's not inside the bracket, so this is up and down. Adding and taking away is a translation. when it's outside of the bracket, it does what you might think. So this graph is going to go down 5. Now at the minute, it's crossing at 1. If we go down 5, it's going to cross at -4. So I'll label my axis at -4. And then I've just got to draw a graph that comes down and goes through -4. It doesn't need to be to scale. The graph looks something like that. Okay? 1 mark for having a graph in roughly the right place, or the same place as me. The second mark for labelling the axis as -4 to say that we've gone down 5. And then the next one on this page, the same original function, f of x, and this time we've got to do a minus. So this is the 3rd time we've done this. So that should tell you something about what they like to put on these exams. The minus is outside of the bracket. We're reflecting up and down. You hardly ever see reflecting left to right, but it does exist. Okay, so now our graph is going to do something like this. It's going to start down at the bottom. It's going to come through there, and it's going to get close to but not touch the x-axis. And for the second mark, we've got to mark the axis. So that point there will be -1 on our reflection. Okay, easy enough when you know the rules. I know all of the rules, so I can do these quickly. It's going to take you a little bit longer because you're not as familiar with the rules. You're probably going to need to keep checking in your book at which rule to use. You'll get used to them though. Okay, next one. We've got a function f of x. It already looks a little bit upside down. And we are being asked to do f of x plus 3. The plus 3 is inside the bracket. Inside the bracket means left and right. Adding goes left because it's opposite to what you'd think inside a bracket. So we're going to the left by 3. The only thing I know about this graph is that the minute it goes through 0. So when I go to the left by 3, draw my new graph. Well, that's quite good for me. It's now touching the axis at -3. So just put a little dash on there and say -3 to say that we've gone left 3. I'm quite proud of that one. Okay, now look, on this one we've got to make 2 transformations. Okay, so it's the same original function f of x. First of all, we've got to do minus f of x. The minus is outside the bracket, so it's up and down. And so if I just do that to start with, it looks a bit like that. Okay, I mean, I haven't quite got through the origin there, so if I move it down a little bit, that's a bit better, look. Okay, should touch the mirror really, because the original one did. So let's label these, because we've got to draw 2. So that's minus f of x. That's just reflecting it. So that's the first bullet point. Now it's asking us to do minus f of x plus 2. Well, we've already done the minus. The minus flipped it this way round. The plus 2, and look where the plus 2 is. It's on the end. It's outside of the bracket. That means it's in the vertical direction. Adding goes up. So now y equals minus fx plus 2. I just need to move my red graph up 2. How do I show that it's gone up 2? I can put a little dot there and label it 2. Okay, so this is minus f of x. The minus because it's upside down compared to what it was to start with. Remember, the black one was the other way round. And then our plus 2, which is how we ended up going through 2. Alright, so 2 transformations on that one. We only have to do one at a time though. Okay. Okay, f of x again, it goes through the origin. I mean, you get quite bored of these after a while. We are taking away 4 inside the bracket, so it's left and right, opposite to what you'd think. Taking away goes to the right, so this graph is going 4 to the right. So anything that looks like that, as long as you mark a 4 on your x-axis. I mean, you could go even further than me if you wanted to. There's no scale, so if you wanted to, you could put it all the way over here, as long as you label it 4. Okay, where you actually put it, there's no scale, that's up to you. Just got to label your axis to show that you went across 4. Now this one's a little bit trickier because there are 2 changes and we've got to do them both at the same time. Except I'm not really going to do it at the same time, I'm going to do them individually. okay, and just leave my final answer there. Okay, so we've got a minus at the front. So the minus there means we've got to flip it. Now you've got pencil, so do this very faintly in pencil. I don't have a pencil, but I can sort of do a dotted version of it. So minus, we've got to flip it upside down. So it's not my final answer, remember, I'm just doing the minus for now. So there's my minus. The other thing we've got to do is plus 2 outside of the bracket on the end, so that's going to go up. So now my dotty one, which I flipped upside down, has got to move up 2. Now this one I'll draw properly because this one is my final answer. So something like that. Okay, so I mean I shouldn't really leave this one behind because it's not part of the question, but this is just with a minus, and then the red one is with the minus and the plus 2. So the red one is my final answer when I've done both transformations, and really in an exam what you would do then is get rid of this one. It helped, but it's not my answer, so just the red one, okay, for your final answer. Now I haven't forgotten to do something. I haven't marked on my axis the number 2 to say that I went up 2. Okay. Not many more of these. How many have I got? Oh, last page actually. Okay. So we've got y equals f of x, and they want minus f of x. The minus is outside of the bracket. I've lost count how many of these I've done in this video. Okay, it's very, very common for them to ask you to do this. This is reflecting up and down. I don't even have any numbers, so all I can do is something like that. Okay. I mean, if they had given me a number on the x-axis, it wouldn't have changed anyway, so what would be the point? It's only worth a mark, that question, because it's so easy. And then down here, you don't see these very often. Okay, this is one of the last ones in my previous video. We've got a multiplier this time. This is a stretch and a squash, okay, like an enlargement. Now, it's inside the bracket. So inside of the bracket tells me that I'm working in the left and right direction. So I'm either making it wider or I'm making it narrower. Nothing else is changing. It's not going up and down. It's not being stretched up and down. You would think that multiplying by 2 makes the graph wider, but not inside the bracket. It has the opposite effect. So this graph is not being stretched twice as wide. It's being forced in half as wide. Okay, these are a little bit tricky. You've got to remember that when you make changes inside the bracket, it does the opposite to what you'd think. Now, hard to do this because we haven't got any coordinates or numbers, but if I sort of move this one in half as close there, and from the right I go in half as close, this one's not going to move. Okay. Now, it's not any taller, it's just thinner. Okay. If I had coordinates, so if I put on an example coordinate, if originally this was 6, 8, because it lined up with 6 on the x-axis and 8 on the y-axis, now my new version of that by there would only be 3, 8. It's very tricky to show how much you've squashed it by when you haven't got a scale to work on, okay? But if you had a coordinate, you could say that it's not sticking out 6 anymore, it's only sticking out half as far, it's only sticking out 3. The 8 doesn't change because the graph is not any taller than it was originally. Alright, so hopefully, having seen a couple of examples and what you need to do to get all of the marks, you can have a go at the other booklets, which is all attached, so give that a go.